One of the first things that we do when we visit a property is we ask the customer about their appliances, how many appliances they've got running off the installation. We need to check all the appliances, we give a visual check on everything, make sure they're all in good working order and they look safe to use. We'll turn everything off. After doing a check of the meter installation, making sure that we can carry on and change the meter, make sure the meter serial numbers are correct, we've then got to go around and check all the appliances that's running off the meter. Every appliance needs to be looked at, visual safety check needs to be done on everything, make sure it looks safe for use, and turn off the appliances. In this installation all we've got is just this boiler. The boiler needs turning off so that we can carry on to test without any gas being used by the boiler. And we'll do that just by turning it off on the customer controls there. We'll just turn it off like that. No gas is being used now, the boiler's off, we can carry on and test the meter installation, the full installation, make sure it's all gas tight. First thing that we need to do when we come to a meter installation is check the meter serial number to make sure the meter serial number matches what we've got on the system. So, meter serial number is the one at the bottom of the index. If we just check that, have a look, and in this case the meter serial number does match what we've got on the system, so we can go ahead and change the meter. Next thing we need to do is have a look at the job, what it entails, what needs to be done to get a new meter fixed into position. Right, the first thing that we need to do before we do any work to the meter installation is check, make sure we've got no stray currents coming from any pipework or any appliances that are on the installation. We'll check his volt stick, make sure that that's working, and then we'll go to the installation pipework, make sure that there's no stray currents coming from anything over there and the volt stick's not lighting up, which is telling me everything's fine. We'll make sure these cables that are up top aren't live. There's a few cables there that have been cut off, they're not live, so we know now we're safe, we're not going to get electrocuted. After checking the installation for any stray currents with the volt stick, the next thing that we do is put temporary continuity bonds on. This is to prevent any arcing of any stray currents that we might not have picked up on when we've got the meter off. The next thing that we have to do is test the installation. This comprises of a let-by test on the main tap, the ECV, the emergency control valve. Make sure that's not passing any gas, and then we'll do a stabilisation period after we've done the let-by, and then a tightness test as a final test. Turn the gas valve off. This is the test point where the manometer is attached to. After doing all the calculations, we've worked it out that we need a let-by test of the emergency control valve of 2 minutes. It's a stabilisation period of 6 minutes, and then a tightness test of 2 minutes again. The let-by test is done at 10 millibar, so we have to let pressure out of the system till it gets down to 10 millibar. And if you look on the manometer now, there's a little line where the water finishes, and that's on 10 millibar, and we have to test that now with the gas valve shut off for 2 minutes. And what we're looking for is gas passing through this valve into the system and increasing in pressure. If it increases in pressure, you'll see that water level there rise up. So we'll now get a stopwatch on and put a test on for 2 minutes. After the let-by test of 2 minutes at 10 millibar, once we've assessed that there's no rise on the manometer in the water, it's still at 10 millibar, we know that we've got no let-by. Then we'll go and proceed on to the stabilisation period for the installation, and that consists of a 6-minute test after we've done all the calculations. Back to the ECV, the emergency control valve, and we'll raise the pressure, and if you watch the manometer you'll see the water level going up, and we'll have that at 21 millibars for the stabilisation period. Shut the valve off, have a check, we're on 21 millibars. Start the stopwatch as long as you're happy that you're on 21 millibars. Start the stopwatch and we're now stabilising the installation. This is to prevent any movement with temperatures, the amount of pipework that's running outside, and any temperatures, i.e. the sun coming out on pipework, that'll expand the gas that's in there by making the pipework hotter. But this stabilisation period should allow for all those processes to carry on in that 6 minutes, and then we'll do a full test. Once I've put the test on for the stabilisation period, I'll then proceed to carry on the PDA to complete the work that's necessary on the PDA to complete the job while the test's in motion. So we'll start the job. I've already checked your details, make sure the address is right, make sure the meter serial number's right, make sure we've got the right name and everything on there. The next thing we need to do is scan the new meter that's actually going in the installation, the new meter asset. We'll do that, we'll take the meter out of the box. And that's the barcode that you'll be scanning. Double check on the PDA, make sure it's scanned correctly. M016K0832 414 Delta 6. So that's what we're checking on there, and that's a correct match. Next on the PDA, select the meter type. It's another U16 meter. Looks completely different to the one that's in, but it still passes the same amount of gas, 16 meters cube per hour. What type of meter is it? Who's the manufacturer? It's an Elster, this one. What does it measure in? All new meters are cubic meters, they're not cubic feet anymore, they're all metric. Cubic meters. Record the opening read. In this case, it's 6 zeros, 0.10. It won't ask for the 0.1, but 6 zeros on the system. Make sure we get the correct reading in. 1, 2, 3, 4, 5, 6 zeros. Next, we'll take a photo of that just to double check and confirm. If there's any queries in the future, we can then email the customers to make sure that we can say that's the meter serial number and that's the correct reading that it started on this date. After finishing on the PDA and finishing all the work that's needed on the PDA, we've already done a stabilisation test for 6 minutes, confirmed that there's no movement anywhere on the gauge. We're quite happy to carry on now and do a tightness test. After calculations, we've determined that it needs a 2-minute test on this installation. So I'll carry on and do a tightness test on the installation now. The gauge has not moved, it's still on 21 millibars. The tightness test is now underway. We've got to wait for 2 minutes now for this tightness test to finish and make sure we've got no drop on that gauge. A drop on the gauge in the water level will confirm that we've got a gas leak. Basically, you're losing pressure out of your installation because the ECV, the control valve that shuts your gas off, the emergency control valve, it's still shut off. So any loss in pressure will tell me that I've got a gas leak as the pressure's lost out of the installation pipework. First thing we do, we start loosening these off. We know all the gas is off. We can take that off. We'll loosen these unions. You'll hear gas coming out that's under pressure, but nothing will follow. We've got the emergency control valve shut off, so that we know there's no more gas coming out. It's only what was in the meter. Again, to minimise the smell of gas coming out of the meter, we've got the new caps off the new meter that's going on. We'll get these ready. We want to put these on the meter inlet and the meter outlet as soon as it's been removed. That's to minimise the amount of gas coming out of the old meter. Now we can go ahead and remove the meter. At this point, I'd take the meter upstairs into my van, out of the way, to minimise the smell of gas in the cellar. before removing the old meter upstairs and back into my van out of the way, we shall be capping this main tap off, making safe, making sure that there's nobody going to come in and turn the valve on and release gas into the premise while I'm up and out at the van. That's one old asset off. If this union that I'm taking off now is a little bit hard to get off, I've got another set of grips that I'll be holding on the back of the valve to make sure the valve doesn't spin off. But first of all, we'll just try it and see if it comes off. Quite often these sort of fittings just pop off with no trouble. As that one has done, it's come straight off. So there's not much need for a second set of grips on the back of the valve to hold the valve in position. A cap with a rubber washer in will seal that emergency control valve while I'm up at the van taking the old assets back to the van. That's nicked up now. If anybody comes in and turns the valve on, we know there's not going to be any problems releasing any gas into the premise. Right, the first thing we need to do, the meter that I'm putting in is actually taller than the one that we took out, so we're going to need to take this bracket off and move the bracket. We shall be putting a new bracket on, but first of all this one needs to be removed. After removing the bracket, as you can see the bracket's been removed now, we're now onto altering pipe work that we need to do to get the new meter into position. And the things that we've got to do, first of all, we're going to remove this part of the pipe work, the meter outlet. And we'll take this off, put a new section in. Part of this alteration that I'm doing, I'm going to put what they call a purge valve on. So this part of the pipework installation I've pre-made in my vise in my van, and we'll be putting this onto the installation now. This is PTF tape that we put on here, or string. It's quite a new product, but it's a gas approved product that we're using to create a gas tight seal. We'll tighten that up by hand, then back to the tools, readjust that. We'll readjust those just to get a proper decent grip so we can tighten this fitting up onto the valve, the meter outlet valve. Next part of the process, fitting your outlet valve. We've got 3 new washers on there for the installation. Take the 3 washers off. This comes as a kit with that cap on. Don't really need that, that's part of a spare. I'll just put those washers to one side. That one, they're on there. Then we need to just put a bit of paste on here. This is gas paste. This will create a gas tight seal around the threads. Up and onto the installation pipework. adjust the grips accordingly. That's after tightening that up. Remove any excess paste. You don't want that on there. That could actually be holding gas back if there's a gas leak on there. We need to wipe that off and make it nice and clean so that we can assess whether there's a gas leak on that joint after the meter's been installed. Straight into the installation of a new washer. That's a new washer on the meter outlet valve. Now we're ready to prepare the installation and put a new bracket on basically. It's a different meter like I said, so it's in a different position. We've got to put the meter on with a bracket. One good solid bracket. Straight in. Start locating your meter. Make sure the rubber washer's still intact and still on the fitting. Make sure it hasn't fallen off. And locate that under there. Ready to tighten that up. That's that one. Next thing we need to do is start putting the governor on, the regulator that regulates gas. The more you ask for, the more it gives you basically. We'll put the governor on, we need to remove that. The new fitting that goes on the emissions control valve that converts the 2-inch control valve to 1 1/4 inch on the regulator is that one. We'll just double check, make sure it's got a washer in. On she goes and we'll tighten her up. And tightened up by hand, well, loosely tightened up if you can call it that. We'll just get it in position like that. Once we've got to a certain tightness, I'll get the other Stilsons on the job. Make sure we're not overdoing it on the tightening up process. I don't want to be spinning that valve. So I'll have a set on one side and a set on the other. Then we come to the fitting of the regulator, which I've pre-assembled in the vise in my van. We'll get the 2 new washers on. One on the end of the anaconda, as we call it, and one on the inlet. Put that into position. Make sure the washer hasn't fallen out. As you can see, the washer's still in place. Just wind that down loosely by hand so we can still turn it to get position to go on the main tap on the ECV, the emergency control valve. Bring that round into position. Check the rubber washer again. Make sure the rubber washer's not fallen out of position. Into place. Tighten it up by hand and then finish it off with the Stilsons again. That's that into position. We can still turn the valve, that's fine. Now we can tighten the regulator up onto the meter. You don't need as much pressure on these smaller fittings, so you don't really need the bigger Stilsons to keep control of the emergency control valve spinning. We're now at a position where we need to start doing a purge, to purge the system out, testing, etc. We'll first put a test on the installation, make sure we're still gas tight. On this part of the installation we don't want any gas coming out into the atmosphere in this premise. Next in the process is purging the installation, the meter. All the installation's still gas tight at the moment, so we have to purge the meter, get rid of the fresh air out of the meter. We need to put tests on in the purging process, make sure none of his equipment's leaking. So I'll put an adaptation on there, a fitting on there. There's purge hose. This is the purge valve that we're using. That'll fasten in there, and we'll get a good gas tight joint on that. After purging, this fitting will be removed, and we'll be plugging the end of the valve off with a plug, a gas tight plug, to prevent any gas leaks coming through the valve in future. If anybody turns the valve on, it'll still be gas tight. Next part of the process is we'll bridge this governor out, and that prevents lock up from the governor. If the governor locks up while we're testing, it'll not be testing this part of the installation, it'll just be testing from the meter inlet up to here. So we need to bridge this governor out to make sure there's no lock up occurs. We'll do that by removing these two screws on the inlet and the outlet of the governor. We'll bridge the inlet and the outlet of the governor with a rubber tube. And when we put a test on, after we've connected the purge hose, we'll be testing all this part of the installation at the same time, just to make sure there's nothing untoward coming from the rubber tube that we've connected. We'll spray a bit of soapy water, basically leak detection fluid, and that'll show if there's any leaks on where the rubber tube's connected to the inlet and the outlet. It'll blow bubbles out of there through the soapy water. Part of the purging process is doing a test on the purging equipment. We need to be gas tight on the purging equipment before we purge. I've already done another let-by test on the valve, on the emergency control valve. That was at 10 millibar, left it for 2 minutes. Assessed that there were no let-by on the valve after we've used it, because these valves could have been stood without being used for quite a long time. Once we use them, they might not be functioning properly, so we have to do another check on the let-by, make sure that's working properly, and then we'll do a full test on the purging equipment. That's a tightness test. Everything that we're testing now, we're testing from here, from this valve, all the way down, round the purging equipment to the valve on the other end of the purging hose, and all this part of the installation, again, the governor's bridged out by a rubber hose, so we know that we're testing the whole of the governor. This test's actually been on already for 2 minutes. We have assessed that there's no gas leaks anywhere on the installation, the purging hose, or any part of the meter installation. We can now go ahead and purge the installation. The gas is sealed inside this purging tube. We're now going to open the valve up and keep taking constant readings with the gas go up at above 2 meters. We're looking for a 90% gas in air reading on the gas go. That tells us that the whole installation has been purged, the meter installation that we've installed, and the gas is being vented to atmosphere. At the same time, we're watching for pedestrians coming up, making sure nobody's smoking or any naked flames that could create a problem. We'll be warning pedestrians. We've got gas, no smoking signs out as well, to make sure that there's nothing going to happen while I'm doing the purging process. At the moment, on the gas go, we've got a 92 gas in air reading, which is telling me the installation is now purged adequately. I can now shut this valve off and seal the gas in the pipe, in the purging hose. The purging process is now over basically. We can now go back downstairs and put a hole test on the installation after removing the purging hose. After a successful purge has been attained, we can now remove the purge hose, take it out of the premise, back into the van outside where it can vent atmosphere from the van and out of the way, reducing the smells of gas in the premise. That's the purge hose out of the way. Fittings that aren't required anymore, they need to come off. That fitting that we used for the purge hose is now replaced by a plug that will seal the gas off from the valve. If ever the valve's turned on, it's still going to be a gas tight seal. On completion of putting the plug in the end of the valve, we now need to open the valve up, leave it in the open position. When we put a test on the installation now, it will be testing that joint there that I just made as well. We're now ready to start a full test all over again. First thing that we need is another let-by test for 2 minutes. As you can see, there's enough pressure in the installation at 80 millibar. We don't want that much pressure. It needs to be back down again to the let-by test pressure, 10 millibar. That's what we test at. So we're just releasing pressure out of the meter basically, so we can do a let-by test. At the minute it's 10 millibar on there. I'll just pop that up there and I'll get my stopwatch and time it for 2 minutes. After a let-by test's been carried out and we're quite happy that there's no let-by, we'll now pump it up and do a full test of stabilisation of 6 minutes and a tightness test on the installation of another 2 minutes. So I'll open the valve up, emergency control valve, repressurise the installation to 21 millibars. And we can get a nice level reading. That's at 21 millibars. What we're testing at the moment is just the meter installation. Right from there, all this piece of pipework, the meter and the governor right up to the main tap, the emergency control valve. It's still got the bridge in on the governor, so we know that we're testing this part of the installation, and we'll test that for 2 minutes. After a 6 minute stabilisation test being carried out, we're quite happy that it's quite stable, there's no movement on there. We're now going to do a full test on the meter installation again, 21 millibars, for another 2 minutes. After we're quite happy that there's no drop in pressure on the meter installation, there's no leaks, we're now going to open up the meter outlet valve and test the whole installation again. If you watch the manometer at the moment, I'm going to open this up and there might be a difference in pressure because this pipework is still pressurised, and when I open that up there might be a little bit of a difference in pressure. There you go, there's a little bit of a difference in pressure where we've lost a bit when we took your meter off, etc. out of that little section of pipework. Repressurise it to 21 millibars again. I've got to do it nice and slow because it bounces up. 21 millibars. We're now going to put another test on another stabilisation test, that is, and we'll stabilise it again for another 6 minutes. After doing a full test of the installation for 2 minutes, we've had the 6-minute stabilisation. We're now quite happy after a 2-minute tightness test. It's all solid, as we call it. It's not got any loss of pressure, there's no gas leaks. We've tested everything on the installation, including the meter and all this sort of section. We've now got to proceed and remove the bypass that we put on the governor. We now need to get to the position of checking working pressures, and we can do that by introducing gas into an appliance and turning the appliance on. We'll have it on full rate, the appliance, so we can check the working pressure, make sure the working pressures are correct. So we'll proceed now to remove that bridge on the governor, replace the test nipples, and then we can put a working pressure on. We're checking with one appliance on full rate. We've got a boiler upstairs that we've got on full rate. We've turned a customer's tap on to make sure the boiler's burning at full rate. Working pressure, as you can see, is 21.5 millibars, which is about ideal. It wants to be 21. It can have 21 plus 2 or minus 3 in this case, industrial stuff. But as it is at the moment, 1.5 millibars is a perfect working pressure. We've now removed the manometer and the test equipment they used to test the installation. As a secondary test, what we do is we'll have a sweep round with a gas go, and then after they've finished with the gas go, we'll actually soap everything up with LDF, leak detection fluid, make sure we've got no bubbles coming out of everywhere. First thing we'll do is we'll sweep round with this, the gas go, and we'll have a full sweep of everything that we can see to make sure there's no gas leaks anywhere that we haven't picked up on. We'll start at the back of the ECV, the emergency control valve, make sure there's no leaks coming from the back of there. That could have spun round and loosened a joint. We're looking for any sort of reading on this gas go, a gas measuring device. As you can see, it's on 0, and that's what we want it to be on all the time. We'll sweep round that nut on the back of the valve. Quite often you'll get a leak on there if you've disturbed it when it's not been moved for 10-15 years or so. Still at 0. Round the back of the fitting that we've put on, still on 0. We're quite happy at the moment, everything's alright. If we do get a read, we can double check it with the LDF, the leak detection fluid. As you can see, the gas is still turned on. We'll come right round this, what we call the anaconda, have a read round there, still at 0. Have a sniff round all these joints that we've made up, and we've still got a good reading. Still got a good reading all around all these joints. Every joint that we've made that we've disturbed, we want to have a look at it and sniff it, see if there's anything coming from any of the joints. The last and final check that we do to make sure everything's gas tight, it's a triple check if you like. You soap everything up using leak detection fluid. We'll start on the valve at the back, give it a squirt all over. Any gas leaks that's coming out of anywhere, including the back of the main tap, you'll see bubbles appearing as the gas blows through the soapy water, and all the bubbles will just blow up and we'll be able to see them. Put some on the anaconda on every joint. Everything's checked and double checked and triple checked. Every joint that we can see on the test point, around the fittings, on the spindle, on that spindle and on there, on that, and away we go. On the test points on the governor that we've removed, we'll do a double check on there as well. As the final check, we're looking for bubbles coming out of all the joints. We'll open that valve up because otherwise that wouldn't leak. If there's a leak on there, we need to see it, we need some gas introduced into that. We'll check around them all, every joint with the mirror. We'll follow every joint round, make sure there's nothing coming out of anywhere, even at the back of the fittings that we can't see. Up and round there. On the governor, every fitting that you've got on the governor, at the back. No bubbles coming from anywhere. Round the back of the regulator there, look. And round the back at this side. Test point on the regulator. We'll follow that up and round again. Make sure there's nothing coming from anywhere around the back of there. As you can see, we've now got a brand new meter installation. It's all labelled up accordingly. We'll close this valve off now, we don't need that open anymore. That's shut off. We've got the emergency control valve label and all the rest of the relevant labels on off tape on the valves that tell you which direction to turn your gas on and off. We've also commissioned a smart device on this meter, an ADM smart device that reads the gas as it's going through the meter. That'll send signals back to your provider and provide your provider with information about how much gas you're using. So that's all been done and recommissioned. We've put a new composite label on there. This composite label's got all the information from the old meter serial numbers, the old meter reading, the new meter serial numbers, the new meter reading, what it started off at. When we commission that smart device, the ADM, it gives you the position of the emergency control valve as well. As you can see, one of the labels that we have got on here, it's a yellow label, and it's talking about a cross bonding, an earth bonding that should be on the pipework. We put these labels on when there's no earth bonding that's connected to the pipework. That should be within 600mm of the outlet of the meter or before any T's. That's not on. Quite often we'll come across installations that's not got earth bonding on, and we'll leave a relevant card, and also we'll give them a not to current standards warning notice that will write out just to say it could really do with an earth bonding putting on your pipework. And that's basically the job finished, apart from the warning notice that we have to write out. And we'll present that to the customer, get him to sign it and say that he's received it, and away we go.